Hey there, Team Impact. It's Thursday. We're going to continue with our ratios. We had a great warm-up. I recommend if you're watching this video at home that you do the warm-up on the previous link up there. It says warm-up and it says click here. But we're going to go ahead and get into this thing. It's the last lesson of the unit. We're going to start a review tomorrow, which is Friday. Continue Monday, and then we'll start testing Tuesday. So let's get into this thing. More of the same what it was yesterday, just kind of working backwards maybe a little bit. All right, let's go. Margaret is traveling a family vacation across the country. Use the given information below, okay? So to find the missing pieces. All right, so what we have to do here is we have to look at this line graph here and kind of work backwards. Well, you know, if she travels for 0 hours, we know that the miles is going to be 0, right? So we know that. All right. So let's go ahead and take a look at 1, and it intersects at 50. 1 hour on our vertical axis is miles traveled. So 1 hour, they go 50 miles, right? 2 hours, 100 miles. 3 hours, 150 miles, right? 4 hours, 200 miles. So looking at those 3 or 4 ratios there, 5 actually with the 0, can we figure out the process or the rule? How are we getting from X to Y? Well, 0 to 0 doesn't help, but 1 to 50 would be times 50. 2 times 50, 3, yeah, it is times 50. So 0 times 50, 1 times 50, 2 times 50, and so on down the line. And let's fill that in because our rule is times 50, right? And this is 6 times 50 and 7 times 50. So we're just going to add 50 on this side just to fill in our miles or the y coordinate, right? So 5 times 50 is 250, 300, 350, right? And if we look at that, it all makes sense, right? 10 times 50 would be 500, and it would be up there, and it would fit right on our line nicely, okay? So what is our equation? Well, we could write this as y equals, right, 50x, or we could abbreviate the m and the h and say m equals 50h. They're the same thing. They're the same thing, right? So no problem there. We don't need a dot. We have a coefficient and so on. So let's answer some questions from this. Number 1, what is the ratio? What is the ratio of the number of hours to the number of miles? Well, number of hours to the number of miles is 1 to 50. I see that clearly right there. How many hours will it take to travel 300 miles? Since I filled it in, I look right there and I can clearly see that it's 6 hours. If this continued with the same ratio, then how many miles would he travel in 15 hours? So if we wrote a 15, it would be 15 times 50 would be our rule, right? And 15 times 50 would be 750. So he would travel 750 miles. So this is just extrapolating it out and taking a look at it, all right, using our function rule or our process. All right, number 4. What does the ordered pair 9, 4, 50 represent in this situation? Well, 9 would represent in 9 hours, all right? In 9 hours, Margaret would travel 450 miles, okay? Makes sense, right? 9 times 50 is 450. If you were given a verbal description instead, explain how you would graph this situation, okay? Well, I could write an equation that would complete the table to determine the ordered pairs to plot, all right? Let's not worry about that. Let's just keep rolling on here, okay? So let's take a look at the next one. Number 6, using the ratio of 7 to 5, complete the table below and graph the values. Okay. Well, this is going to be fun. So I know for my x's first, 7 and 5. And we're going to scale this up. So I'm just going to go times 2, times 3, times 4, and times 5. All right, so 14 and 10, 21 and 15, 28 and 20, 35 and 25. And I just scaled both of these up by that factor that I've written above there. That makes it easier for me, right? Okay. So let's take a peek at this letter A. Using the information above, set up and solve a proportion to determine the value of y and x, all right, of y when x is equal to 49. And what is the scale factor? What is the multiplier? All right, so what I would do is I would set up my initial ratio. This is x and this is y, correct? But we want the x factor, to be 49, all right? And what is this value? And you know what, I shouldn't use there, I'm going to use y. What is y? Okay, well, we can clearly see it's times 7 times 7, right? So y is going to be 35. And that's using a proportion, 2 equal ratios, okay? Now, the last piece of this is going ahead and setting up our coordinate, our graph here off the coordinate plane. This was x, remember this is y. This is a point of origin, 0. So what I'm going to do on my x is just count by sevens, and I'm going to skip a space to leave me an interval in between. I'm going to guesstimate if it does end up there, but it won't because we're talking about multiples of 7. So we have 7, skip 1, 21, skip 1, 35, skip 1, 49, skip 1, and 63. Okay, and I just kind of guessed there and went with it. All right, now I'm going to go on my vertical axis, and here we go. I'm going to count by 5s because the y-axis is 5s, and I'm going to skip 1, 5, skip 1, 10, 15, skip 1, 20, 25, skip 1, 30, 35, skip 1, 40, that's 45, okay? Now we're going to go ahead and graph our ordered pairs. X is 7, Y is 5, right there. All right, now we're going to guess here a little bit. Here's 7, here's 21. I'm going to guess somewhere in here. X is 10, Y is 14, so I'm going to put it about right there. And your dots are going to depend on where or what interval you used. I just used 7s across there. The next ordered pair is X is 21, Y is 15. Okay, and we have a problem. So our problem clearly is that doesn't fit in there. My guesstimation was off. So when it was 14, this should have been 10, and 10 would be there. So that is actually wrong. And that happens sometimes, right? All right, let's jump up to 28. When X is 28, here's 35. All right, so I'm going to say, well, here's 21, 28. Here's the interval, right? And this is 20. So let's go up to here. And then finally, when X is 35, Y is 25, and it's right there. And clearly, let me pull my protractor out. We can see that my line works better. So if you make a mistake, and I couldn't erase it because I'm using pen so you could see it a little bit better, but there it is. So 7, 14, 21, 28, 35. These are intervals of 7 going across there. Okay, let's take a peek at number 7 and go. The relationship between the number of hours traveled and the number of miles traveled on a family road trip is graphed below. What is the ratio of hours to miles? 1 to 50. That it is, 1 to 50, right? Number 2, or letter B. How many miles could the family travel in a period of 12 hours? Well, it only goes to 10. Well, how can I do this? Well, I could set up a proportion, right? And I'm going to do that over here, 1 to 50, right? And this is hours, and this is miles. So how many could travel in a period of 12 hours? Now that's X. So I'm going to scale that up times 12. 50 times 12 is 600 miles. 600 miles. How many hours would it take, excuse me, the family to travel 700 miles? Well, let's go ahead and set this up again. My initial ratio is 1 to 50. This is hours, and this is miles. I want 700 miles. What is X now? So I need to figure out the relationship between these two numbers. And let's take a peek at that. So I'm going to use my calculator here. And I'm going to take 700 and divide it by 50, and I get 14. So that means 50 times 14 is that. 1 times 14 will give us X, and X would be 14 hours. Okay? All right, good stuff here. Let's move on. The relationship between the number of bread loaves and the cost of loaves is in the ratio table below. 2 to 5, 4 to 10, and so on. Graph the ratio and answer the questions. Okay. Well, 2 loaves cost $5. So that's about right there. 4 loaves cost $10. That's about right there. 6 loaves cost $15. That's about right there. We have a good intersection there. 8 loaves, $20. That would be about right there. And it does become linear. So we can draw that right so, and we can go like that. Okay, well, how much would 12 loaves cost? All right, well, let's write our initial ratio down. I have 1 to 3 loaves to money. I don't want 3 loaves, I want 12 loaves. What is X? Times 4 times 4. X is 4. X would be, not $4, excuse me. I've made a mistake here. Let's go back here. 1 to 3, loaves to money. All right? All right? How much would 12 loaves? You see what I did? I put 12 on the wrong side. So it should be 12 over X equals, I went too fast there. So how do I get from 1 to 12? I multiply it by 12. 3 times 12 is 36. And I'm going to write $36 right there. I knew I made a mistake because it didn't cost enough, because 1 loaf was $3, all right? So that was a problem. If Annie has $47.50, how many boxes of bread can she buy? Ooh, okay, well, let's go ahead and set it up. 1 loaf is $3. She has $47.50. How many loaves can I get? All right, so clearly we're going to need our calculator here. So I'm going to take $47.50 and divide it by 3. And I get some crazy number, right? So to get from here to here, I multiplied it by $15.83, approximately. So, all right, how many loaves can I get up top? Well, 1 to scale it up is times this, right? All right, sorry, I was having a coughing fit there. But anyway, we're going to multiply this by 1583, and we're going to get approximately 15 loaves. 15 loaves, okay? All right, so it is Thursday, We've just gone through that. If you flip the page, here is your homework. Independent practice, ratios on the coordinate grid, and there you have it. Have a great day, guys.